Welcome to full solutions of lesson 5 of vectors, which is on algebraic operations. In this question, we're given two vectors and we're asked to do a few operations on them. So first I'm going to write them in a different form. I'm going to write vector A as -1 because it's negative I, and that's the x component, and +3 for the y component. And vector B has x component of 2 and y component of -1. Part A of the question is asking us to do a subtraction, so we simply write this as the x component of A minus x component of B, and y component of A minus y component of B. And when we do this, -1 minus 2 is -3, and 3 minus -1 is 3 plus 1, which is +4. Okay, for part B of the question, we got 2a minus 3b, or 2 times vector A minus 3 times vector B. So I'll write that here. 2 times the x component of vector A, which is -1, minus 3 times the x component of vector B, which is 2, and the y component of vector A is 3, minus 3 times the y component of vector B, which is -1. Once I have this, 2 times -1 is -2 minus 6, and 2 times 3 is 6, and -3 times -1 is +3. And when I do the calculation, I get -8 and 9 as my final answer. For part C, we're looking at the magnitude of 3 times vector A. So let's find 3 times vector A first. We have to multiply each component by 3, so 3 times -1 and 3 times 3, and when I do that, I get -3 and 9. So now I want to figure out the magnitude. So the magnitude is the square root of the x component squared plus the y component squared. And this will give me 9 plus 81, which is equal to square root of 90. Square root of 90 can also be simplified, so it can be written as square root of 9 times square root of 10, and this is the same as 3 square root of 10 unit as our final answer. We can also put this on our calculator and find it to 3 significant figures, but especially if you're writing a test, which is a paper 1 or a non-calculator based test, then you usually have to write your final answer as exact value like this. We have a bit more space on this page, so let's do D as well. We have to find the magnitude of -2b. So let's find -2 times vector B first. It will have an x component, which is -2 times 2, and y component of -2 times -1. This will give us an x component of -4, and y component of 2. Now we want to find the magnitude of this, so we are going to do square root of the x component squared plus the y component squared, and we get 16 plus 4, which is equal to square root of 20, or root 20. This can be simplified. We can write this as root 4 multiplied by root 5, and that's same as 2 root 5 as our final answer. Okay, we need a little bit more space, so let's do part E of the question on this page. So as a reminder, we're going to do vector A. A's component is -1 and 3, and vector B's components are 2 and -1. So in this question, we need the magnitude of -3 times vector A minus 2 times vector b. So let's see what that vector is first, because that's within the magnitude sign, so you can kind of treat this as a bracket. We need to do this first before we find the magnitude. So to do this, I will write the -3 times the x component of vector a, which is -1, minus 2 times the x component of vector b, which is 2, and minus 3 times the y component of vector a, which is 3, and minus 2 times y component of vector b, which is -1. By doing this, we get -3 times -1, which is +3, minus 2 times 2, which is 4. -3 times 3 is -9. -2 times -1 is +2. And we do the calculations, and we get -1 and -9 plus 2, which is -7. We now need the magnitude of this, so the magnitude of -3a minus 2b will equal to the square root of its x component, which is -1 squared, plus the y component squared, which is -7 squared. Putting this into our calculation, we get 1 plus 49, and that's square root of 50. This can be broken down to square root of 25 multiplied by 2, which is same as 5's root 2 as our final answer. I hope that the video has helped you a little bit with algebraic operations on two-dimensional vectors, and thank you for watching.